Hey, it's Slynk here, and I thought today we'd take a look at the inside of DuckBuddy in Maxforlive and check out how I built it. Now, I'm not really sure how to do these videos. I don't want to assume that you all have all the basic knowledge of Maxforlive, so maybe I'll treat it as more of a kind of Maxforlive tutorial where I assume that you guys are kind of new to Maxforlive, and that way I can share some helpful tips that I wish I knew when I first started. So as you can see, there's quite a lot to cover inside of this patch, but I think before we get to this kind of stuff, we should just talk about Maxforlive and audio in general. Yeah, so maybe let's just start with a few things that will help you understand how Maxforlive works. So let's just start with a new Maxforlive audio effect, which you can find in here, and just drag it there and then click this little button to open it up. And now we're making our brand new Maxforlive patch. Let's zoom in a little bit, and we'll also open the inspection panel, and clicking into the patch and clicking this P shows us the patcher inspector, and we can scroll to the bottom and click this button here, and that will open our patch in presentation mode. So now we have two views: presentation mode, which is what it's going to be looking like in Ableton, and then this is called, what's it called again? Patcher mode. So this is where we can stick all our wires, we can hide all our wires, you know, behind the TV, right? Let's just delete all this stuff. If you're going to get started with Maxforlive, you got to think about audio as being a number from 1 to -1. Imagine a speaker cone pushing out when it gets a 1 and sucking in when it gets a -1, and then doing nothing when it gets a 0, right? That's kind of a good way to think about it. So that means that if I just push the N key, N Vanelli on my keyboard, we can create a new object, and we'll create a multiplication object. So we want to be affecting the signal, so we need to use this multiplication object with the squiggly line after it. And this takes two inputs, the thing we want to multiply and the number we want to multiply it by. So if I hold Shift and drag it in here, I can just and hold Alt, and then we can put it in there. So now we have a multiplication object between our plugin and plug out. So the audio coming into the plugin and then leaving the plugin. So if we give these multiplication objects a number to multiply by, then we're going to be changing the volume essentially of the signal. So let's just push the F key, and now we have this is like a little number box. It's called a number. And we'll just connect that to here. And it might be a good idea to set some minimums and maximums. So the minimum should probably be 0. And the maximum, let's just make it 1. So we can't make the signal too loud. So imagine we have a 1 coming in here. That's the loudest signal possible. And we multiply that by a 1. Then we're going to get a 1. Right? And if we multiply the 1 by a 0, we're going to get nothing. It's going to be silent. So what we'll do is right click on this and go add to presentation. And now in presentation view, we have our little number box. And let's just save the patch as example gain and close it and see what happens. So I can play a donk here. Let's turn this off. Go. We got a donk. Essentially, that is the core of how DuckBuddy works, right? All we're doing is turning the volume down on the signal. Yeah, we're basically just multiplying the signal by a number, and that number changes according to the curve and whatnot. Actually, I want to show you a couple other things here. So in the debug menu, you can turn on event probe and signal probe, and this is going to make your Maxforlive life a lot easier. When I mouse over this cable here, I can see that a 1 has passed through this cable. And if I change this number, now you can see, okay, a 0.61 went through there. So this can be really helpful for diagnosing, like, why didn't my message go where I wanted it to go? And even on the signal here, like, you can see a tiny little waveform, which shows you that there's actually audio passing through there. It's really helpful. Now, another object that I use a lot is the send and receive object. So if I push the N key for a new object, it's just S for short. And then when I push space, it tells me that it needs one argument, which is the name. And if that name has 3 dashes in front of it, that means that this send and receive pair will be completely local to this device only. So if I have a copy of this patch in Ableton, it's not sending to all of them, like broadcasting globally. So if I did want to broadcast globally, I wouldn't put the 3 dashes. But anyway, let's just call this send a gain, right? And then we can hold Alt to copy it. And then we'll just call this receive gain. So what we could do is, instead of connecting over to here, we can connect to this. And now we're sending the message from here to here. And we can confirm it's working. Okay, a 0.7 come out of here. And then look at this, a 0.7 came out of there. So this is pretty helpful to just like organize your patch a little bit better. And I like to color them so that things are color coded, you know. If I have a different pair, then it's easier to see what's going on. So maybe I'll just show you the signal flow inside of DuckBuddy. So we've got the plugin 1 and 2 here, and a plugin 3 and 4. This is for the auxiliary channel that you select for the ring modulation input. And those both go into an MC pack. MC just stands for multi-channel, so you can pack a left and right signal into one cable. And that, along with a bunch of other stuff, goes down into this MC Gen patch, which I've titled Apply Gain Reduction. And this is where, well, it's the brains of DuckBuddy, and this is where the gain reduction is actually happening. All the math and everything to calculate how to apply the gain reduction happens in here. And it's pretty complicated, so we'll get to it eventually. But the result of that comes out of these 4 outlets, and some of them go this way into this route output signal, and this is a subpatch which routes the stuff different directions, and eventually we come out to a plug out, exiting the plugin. We also have the signal coming out here into the scope menu, into our little peak detection setup. This is just a volume meter and whatnot. So I've also color coded all of my subpatches, this kind of purple color. So anytime you see a P and then a title, that's a subpatch, and you can control double click to open it up and see what's happening on the inside. And this here is a BPatcher. So it's similar to a subpatch, except that you can also see the stuff. It has its own presentation view, and you can edit that. This can be an external file, or it can be embedded inside the patcher. See, embed patcher in parent. So I've got that turned on. So check this out. If I create a new object and type BPatcher, and then I click this button, I can control double click, and that opens up the subpatch that we just created. And if we go to presentation view and put something in here like a knob, right? You can see what's happening, right? We've got it over here, and I can even move this knob. Now this knob could be connected to an outlet like this. And now we have an outlet here, and we could be getting the number coming out of there, even though this is a subpatch. So a lot of that sort of thing is happening in this BPatcher. One other thing to note is if I create a send and receive pair, let's just create a send called demo. Even though the send is in this BPatcher and the receive is in the main patch, we can still communicate. So I thought it'd be helpful to just explain how that all works. Regular patches, just a subpatch, will give me just a little object like this. So then I can create an inlet and an outlet and do stuff. Let's multiply by 0.5. And if I create a message box and put the number 2 in here and connect the exit of this into the second outlet. So this will set the message inside the message box. And the outlet, if I control click this, it'll send the 2 out of here into our patch. The patch does magical things and we get a 1 out the bottom. So that's basically how subpatches work, and they're really easy to create. What else is cool is if I had something complicated like, well, not even complicated. Let's just do something easy for an example. Say we got this multiplication object. I wish I knew the hotkey. I should probably learn it, but edit, encapsulate. Now it's a subpatcher and I can control double click it and that object is in here and I can create inlets. And so yeah, basically if you have a huge mess of wires, you can kind of just select it all, encapsulate it into one object and then keep things a little bit more organized. Okay, quick side quest, but over on the Cycling 74 website, they put an article out called What's New in Live 11 Part 1, and there's this handy zip file that you can download. And if we scroll down a bit, inside the zip file, you'll find this MIDI routing example patch, and it's really handy because routing channels, especially MIDI, actually any channels, is really annoying and difficult if you don't know what you're doing. And like me, I don't know what I'm doing, so I basically just used this example in DuckBuddy to do the MIDI and audio routing. And I've just opened the patch up here so you can see what it looks like. So I don't care about the colors or any of this stuff or this or any of this stuff here. All I'm interested in is this routing thingy and these menus and also this message box here. So if we go into this routing subpatcher, you can see that there's more subpatches in there and here, and there's another one in there, and it's using this crazy Ableton API. I don't really understand any of it, but what I did understand is this part here where it says the argument is a symbol and you can give it audio input, audio output, MIDI input, MIDI output. So basically whatever this message is set to, that's what we're going to be choosing with these menus. So I've taken this kind of abstraction and implemented it into DuckBuddy in the input selection menu here. So this BPatcher, if we control double click it, we can open it up and take a look. This is the presentation view, but in the patching view, we can see we've got 2 U menus and the routing patcher, which is doing all the same things that we just saw, except I've removed the color stuff and whatever. And yeah, MIDI input 1, MIDI input 0, and audio inputs 1. So the audio inputs 1 refers to the plugin 3 and 4. If I put audio inputs 0, then that would refer to the plugin 1 and 2. And we don't really need to select that because this is an audio effect and it's already getting that audio from the plugin. And we can't select more than one MIDI input, I believe. So you can only do 0. This receive object, LB, I've kind of shortened load bang to LB, and we're sending a load bang here. So this device and this load bang here, these are special objects that if you look at the help file again, the help file is very handy. Basically, it sends a bang automatically when the device loads, which is all you really need to know about that. And then this outlet here, it tells you whether the device is on or off. So if we go to Ableton and turn the device off, then that's sending a 0 out of this cable. And if we turn it back on, we have a 1. So I'm putting that into this active send object. And this is another style of basically loading and banging. I just added for redundancy. I'm not sure if it's necessary actually, but I thought maybe I was getting some problems with this device not actually banging when it should be. So I'm putting this in just in case. And it's just also doing another bang, I guess. And this is the DSP state object, which basically just tells us what sampling rate we have. So if I get a message box and I'm going to push B to create a bang object, I can bang this DSP state object and I can see that I'm sampling at 48,000. So I kind of just made these 3 sends in this little area that I can use all throughout the patch. So I think the next logical step is to take a look at this shape and how that works, because this is, after all, the shape of the gain reduction that we're doing. So let's take a look inside this BPatcher to see how that works. So let's go into patching mode, and up the top here, we've got the shape down here, but up the top here, we've got the scopes that happen in behind the shape. And then over here, we've got these kind of indicator areas. This is just all stuff to make it look pretty. So, you know, when there's a peak, this part is a bit red. There's this little readout here and that sort of thing. But this is where the actual shape is being created and used. And this is what's called a function object. So I can create a new one, function. And yeah, I can start adding points and stuff. There is a bunch of options in the inspector here that you can change. So we can change the color of it to, you know, the line is now red. And if we click this button down here, the attribute names, if I show them, I can see it's the color, but it's actually called line color. So what I can do is send this object a message saying line color, and then I believe it takes 3 numbers, you know, RGB. So let's just go 100, and let's see. Yeah, now we have a more red line. So that's a way for you to like change options in an object without just clicking it and doing it manually. So let's just start with a fresh function and try to understand how it works. So we have 4 outlets here, and if we mouse over them, we can see what they do. Okay, this one gives us all points in line format. This one gives us interpolated, whatever that means, dump message, bang when value changed with mouse. Okay, so what are we using over here? We're using the last 3, but this one is the most important one. All curves, all points in curve format, right? This says all points in line format. So there's definitely some option in here. We've got mode. Let's change that to curve, because we do want a curvy line after all. Okay, all points in curve format. So that's great. So this goes to the send and receive pair here, which I can control double click on to show you where it's received. The list of points and coordinates and stuff from the function goes into here. It gets organized and eventually goes into a curve object, which sends out a signal to our gen patch to help the gen patch know how to do the gain reduction. And we'll explain that eventually. But let's just try to understand how this works. Let's just grab a message box and see if we can understand what these numbers are doing. So I'll put a point in here and nothing's happening. We're not getting any information out of here. Nothing coming out of the cable. Okay, so we'll bang the inlet here. So we can see here, bang outputs all floats, right? So basically, if we give it a bang here, it's going to actually output the information that it has. Boom, we got a 0. Okay, let's put another point over here. And by the way, the ranges we're talking about, we have just as default, we've got the x-axis, which is this way, 0 to 1,000, and the y-axis is 0 to 1. So we should have 0, 0, and then 1, 1,000, right? Okay, kind of. Well, there's a third number for how curvy it is. And that is a range of, you can actually see it in the readout at the top of the function there. It's a number from between -1 and 1, with 0 being not curvy at all, right? But how come we're not seeing the first point? Well, let's make sure that we are getting all the information here. We'll use a print object and connect the wire to that. And then let's open our Max console, which I always have open on the other screen. And let's see what we get out of there. Okay, so we've got a 0, then we have a 1, a 1000, and the curvy number. So it actually is giving us the points, the numbers for both points. It's just happening one after another. So if we have a third point in here, now we're going to get first the 0. Oh, hang on, this is a little bit different, isn't it? So first we get a 0 for some reason, and then we get the rest of the coordinates and stuff. We have 0.6, so that would be the y coordinates, and then 421, that's the x coordinate, and then how curvy it is, 0. And then next we have 1, and shouldn't that be 1000? Actually, it's this first number plus this number, which will be 1000. So it's not actually giving us like coordinates necessarily. It's giving us like traveling direction kind of thing. So first we start at 0. Then we want to go up 0.6 and across 421. Then we want to go up to 1 and across 578 with a bit of a curve. Okay, so that's kind of how that works. And it's important to like really understand how these numbers work in order to use them, right? Because they are going into here and eventually doing things. I'm not even sure if I remember how this works, to be honest. You know, at least this gives you a good way to kind of try to start figuring it out for yourself. Like we're looking at these values coming out of here. How can we use them, right? Well, if the bottom is 0 and here is 0.5, what if we multiplied the signal by 0.5? It would be half the volume, yeah? So what we need is a way to multiply the signal by all of these numbers in between. And for this amount of time, right? So this being 0 and this being 1000, how much time is that actually? And we want to be able to change that amount of time too over here in the length setting. So maybe we want it to be 200 milliseconds, maybe we don't. So we need to take this second number and kind of scale it according to our length so that the overall length of all points adds up to 200 milliseconds, for example, right? So that can get pretty crazy. Okay, well, it's not actually that complicated. We can see here all points in curve format. What is a curve format? Well, let's load a curve object and take a look at it in the help file. And we can see that it says object to produce a signal that goes from an initial to a target value over a specified time. So we are going from 0 to 1 over 500 milliseconds. And that kind of lines up with the numbers we were seeing on our Max console here. You know, we have a 0, so start at 0 and then go to these coordinates. So it is in curve format. So we can just connect this to this, and now this curve is creating a signal based on this kind of list of numbers. So to visualize that, we will use a live scope. And by default, the scope's range is from -1 to 1 because it's used to look at audio, which, as we discussed earlier, are numbers from -1 to 1. But we'll set this to 0 to 1 because that's our y-axis here. We've got 0 down here and 1 up here. And now we should be able to see that line go up. Yeah. So the line travels up. So if I had a signal and I multiplied our signal by this number, which it's essentially a number coming out of here, we would be getting volume changes that look like this. So that's pretty cool, right? Another way to look at this is to use a number object, not a number object, but a number for signals object. And we can connect that to here. So we can see, okay, we're getting a 1. We can't connect a signal to this because it's not a signal object. We can see 0 and it goes up to 1. We can change how fast that happens by changing the update interval here. It goes 0 and then 1. So at least we get the count there. So that's the number that is being multiplied by our signal in a way. And that's kind of what we're doing over here inside our master apply gain reduction patch. But how much time is this? This is 1000 milliseconds by default, and we want to be able to change that. So we've got to figure out how to do that first. But I think that might be a good place to stop the video. It's already getting kind of long, and I'm not sure how many of you will actually be interested in this kind of thing. So rather than spending tons of effort making a super sick video that 5 people will watch, I'll start with this. I feel like I've given you plenty of Maxforlive tips and tricks along the way here while explaining this. So if you do enjoy these kinds of videos, I've never really made a Maxforlive video before, but if you do enjoy it, then let me know in the comments, and if there's enough interest, I'll continue explaining how this all works. I think it's really interesting. My partner does not, so it is, I guess, therapeutic for me to talk about how this all works, because some of the problems that I solved in here are downright clever, I gotta say, and I want to brag about them. So yeah, let me know what you think of this video, and stay tuned for the next one. All right, peace.